Okay. Hi, everybody. A very good evening. Am I made the host? I'm sorry. Where is this? Yeah, I think the host has to be changed. Good evening, Strayan. Yeah, I'm the host now. Right. Okay, let me share my screen. Right, obviously today we'll be seeing biomolecules. Right. So we'll quickly finish it. Right. So first, a carbohydrate which cannot be hydrolyzed to simpler compounds. What is it called as? Very simple, monosaccharides, right? Whereas polysaccharide is going to give me more than 10 monosaccharides. Trisaccharide is going to give me 3 monosaccharides, and disaccharide is going to give me 2 monosaccharide units on hydrolysis, right? So all your glucose, fructose, mannose, glucose, whatever you have, all these are monosaccharides. Whereas disaccharides, for example, if you go for starch, right? That is an example for disaccharide. I mean, no, starch is a polysaccharide. Disaccharide example, sucrose is a very good example because it is going to contain 1 glucose and 1 fructose. Is it not? The answer for this question would be monosaccharide, which cannot be further hydrolyzed to any more simple compounds. Monosaccharide is the simplest, right? Fine. Next question. Glycosidic linkage. Now remember, the glycosidic linkage will be present in disaccharides or in general polysaccharides, right? Disaccharides. Right? What do you understand? Say I'm going to have, for example, if I take your, sucrose, right? Now you'll see that this is how your glucose and fructose are connected. This is C1 of glucose and C4 of fructose. These things you have to remember, Kanas, right? Which carbon atom of which monosaccharide is attached, right? And this linkage which you see here is nothing but an ether linkage. Is it not? COC bond linkage. And this ether linkage is what is called as your glycosidic linkage, right? It's called as glycosidic linkage. What kind of linkage your polypeptides has?
Peptide linkage.
What linkage?
Peptide linkage.
Peptide linkage. Okay, what peptide is what kind of bond it is? Now we are saying that it is a glycosidic linkage, is ether bond. So peptide is what kind of bond or what kind of functional group it is? This is what you have, right? You have C double bond O NH is what you will have in case of any of the peptide. This is what is called as your peptide bond. What functional group is this? C double bond O NH.
Amide.
Amide, right? In case of peptide, it is going to be an amide linkage, right? So anyways, the answer for this question would be an ether linkage. If they ask you about a peptide linkage, then the answer would have been an amide linkage, right? Okay, next. When a nucleoside is linked to a phosphoric acid, which one of the following may be obtained? Now, please understand, people. Nucleoside is 3 things. It is going to contain 3 things. One, it is going to contain your sugar, and second one, it is going to contain your base, right? This plus this will give you something called as nucleoside. And this nucleoside, if you use your phosphate, right? And this entire thing now is going to be called as your nucleotide. So nucleotide. S becomes P. Okay, now very simple. So sugar plus base is nucleoside. That is what they're now. Nucleoside is nothing but a sugar plus base, right? And that linking with phosphate to give you a nucleotide. So answer of this question would be B. Someone in the chat said something. Yeah, nucleotide is the answer. Absolutely, yes. It's correct. Right? Okay, next question. Hey, why is it like this? What happened? Oh, okay, it went. Okay, the most appropriate base pair in double helix of DNA. Now you understand that there are combinations are possible. Adenine with cytosine, guanine with thymine. Correct only, right? A with, no.
Sir, A with T and G with C.
Yeah, exactly, correct. AT and GC. This is what is the base pair. Or you can even have AU and GT. Sorry, GC, right? This happens in RNA, obviously, because uracil is and thymine are different, right? And obviously, this is going to be happening for DNA, right? So AT is correct, AC is not correct, CT is not correct, EG is not correct, AT is the correct answer. Right? Next, which of the following is not common for RNA and DNA? Which is common for RNA and DNA? They are polymers of nucleotides, absolutely. Or both RNA, any nucleic acid, right? Any nucleic acid for that matter, will say that it is a polymer of a nucleotide. Because the things are going to be common. Base, sugar, and your phosphate is going to be common for both of them. Again, what sugar you use in your RNA? In RNA, the sugar used is deoxyribose. No, sorry. Here it is ribose, the sugar, right? Whereas in DNA, we use what? We use deoxyribose. Right? And the base is also different. 3 bases are common. Adenine, guanine, cytosine is common. Right? Whereas in RNA, we are going to get uracil. In DNA, we are going to have thymine. That is another difference. Right? And obviously, DNA is going to be a double helix structure, whereas your RNA is going to be a single helix structure. Right? Okay. Fine, we'll try to understand. So these are polymers of nucleotides. Is okay. This is the correct answer. They're asking, but that's not the correct answer, but statement is correct. Okay. So they contain heterocyclic base thymine. Now, obviously, that's not right. DNA contains thymine, whereas RNA contains uracil. So this is not the, and they contain pentose sugar. Yes, both your ribose and deoxyribose are 5-membered rings along with oxygen. Right? So pentose sugar, and these are chiral molecules due to sugar component in them. Obviously, this deoxyribose and ribose, you'll be able to write them as CHOH, HOH, OHH, all these you can write. All these are definitely going to be chiral molecules, right? So definitely these are correct statements. So this cannot be the answer, but this is a wrong statement. So that is the answer, right? Okay. Next, which of the following is the complementary base of adenine? Again, adenine is going to bind with what? A with T, thymine is the answer, and guanine with cytosine, G and C, right? Next, which of the following is a basic amino acid? So again, you have to understand that you don't have to remember the exact structure for all the 23 amino acids. It's really not required, but you have to understand what is special about all of these acids, right? Serine, if I remember, it is going to contain OH group, right? Alanine is nothing but CH3, CH, COOH, and NH2. Nothing, one hydrocarbon, that's it. Tyrosine is going to be a tyrosine again is going to contain some OH. Okay, so but lysine is the one which is going to contain some extra NH2. That means you are going to have CH, NH2, COOH, and some R, right? Right now, this R, one of the carbon atoms is going to contain an NH2. Obviously, we know amine groups are basic in nature, right? So, answer for this question would be lysine. Okay, that's a basic amino acid. Next. An example of a globular protein. Okay, now these are memory-based questions. The answer for this question would be albumin. Okay, what is an example for a fibrous protein?
Keratin.
Yes, very good. Keratin. Right, keratin is an example for fibrous protein. Albumin is an example for globular protein. What is the basic difference between these two? Globular protein and fibrous proteins.
Can you repeat, sir?
I'm asking you, what is the basic difference between fibrous proteins and globular proteins? What is the difference between them?
Fibrous will be like strands and globular will be
like globule. Like this is how you represent a globular protein. But in case of fibrous protein, we will represent them like this. This is a fibrous protein and this is a globular protein. Like a globule under irregular shape. Right? Fibrous proteins means like a fiber. If you look at your any cloth and you look at it under the microscope, you will see only this kind of structures, lines running parallel and horizontal and vertical. Okay, that is one of the basic difference here. Anyways, okay. Next, proteins are found to have different types of secondary structures, namely alpha helix and beta pleated sheets. Yes, we know. Alpha helix of a protein is stabilized by, right? Now, alpha helix is what? Now, say I am going to have one linear chain, right? I'm sorry, right? Say I am going to have one linear. This is your primary structure. Say lysine, alanine, some amino acids are there, right? Now, what you understand is this is going to get folded into something like this. This becomes like this. That means what? You understand that this particular part has to interact with this particular part somehow. Is it not? Right? So obviously, what kind of interaction they are going to have? These are hydrogen bonding. They fold due to hydrogen bonding. That's the answer to this question. Okay. Now, hydrogen bonds will be the answer. Okay, fine. Moving on. Maltose on treating with dilute HCl. Now, maltose is a disaccharide. Yeah, this and all we have to know. Okay, maltose is a disaccharide. Now, when I go for dilute HCl, this is nothing but hydrolysis. Don't worry about what is HCl going to do. Dilute HCl means mostly it is water, right? So on hydrolysis, it is going to give me my monomers. That is what is going to happen, right? It is going to give me my monomers. What are the monomers present in maltose, people?
Glucose and fructose.
No, maltose. No, correct. Glucose and fructose. No, maltose is glucose and glucose. Maltose is, yeah, glucose and glucose. Yes. Okay, so obviously you're going to get what? Only D-glucose. If it is sucrose, it is glucose and fructose. Right? What about galactose? Oh, sorry, not galactose. It's called galactose is monosaccharide. What is it called as? Maltose?
Lactose.
Lactose, absolutely, yes. Right? Lactose is going to give me glucose plus galactose. Okay, three only you have to remember. Sucrose is glucose and fructose. Maltose is only glucose. That is 2 glucose units. And lactose is glucose plus galactose. Okay, right. Next, thiol group. Again, this and all you have to remember. These all are very, very important questions. Thiol group is going to be thiol is what? SH, right? You will see it is going to be present only in cysteine, right? That R, CH, NH2, COOH. Now this R, in somewhere in the ring, it is going to contain some SH. That's why it's called thiol group present in which amino acid? This is an amino acid. All these are amino acids, except for cytosine. Cytosine is what? This is a base. Is it not? Which comes in your DNA or RNA. Right. Cysteine spelling is also wrong. This is the correct spelling. Okay. Fine. Next, DNA fingerprinting. Yeah, we know, right? You might have seen so many movies, right? So DNA fingerprinting is determined paternity of individuals in forensic laboratories to identify racial groups, and all of these. Obviously, all of these can be used, right? Because similar race people will have almost similar DNA, right? Forensic laboratories, for example, say if you going to a crime scene, say you found a hair strand, right? You will take that hair strand to DNA analysis, right? You might have seen so many movies, right? And paternity, so many cases, right? You will be able to see match, and the DNAs and DNAs of the mother and the child will match, father and child will match, right? So again, you'll be able to use that. So all of these will be the answer. Okay, right. Next, cane sugar. Cane sugar is nothing but what? Cane sugar is
Sucrose.
Yes, cane sugar is sucrose. On hydrolysis gives what? We have seen so many times, glucose and fructose. Right? Okay, next. Nucleic acid having the nucleic acid having 2 hydrogen binding sites. Okay. Right. So what we have to understand is between adenine and thymine, there are
2 hydrogen bonds.
2 hydrogen bonds. Right? But between your guanine and cytosine, you have 3 hydrogen bonds. Right? So either guanine or cytosine or 2 binding sites. So either thymine or adenine both will come.
So should we see according to its structure?
Yeah, we have to do a paper about structure. Okay, remember this. Okay, adenine and guanine are what are called as your purines. No, right? And then your cytosine, thymine, and uracil. All these are called as pyrimidines. Right? And purines always have 3 sites. Sorry, adenine, guanine, thymine, uracil. No, the question is wrong. Right? The answer for this question would be both thymine and uracil. Both of them will have 2 hydrogen bonding sites. Or it should be only thymine, I guess. Uracil will not take because it's not even going to have any kind of double helix. It's only going to be DNA which is having double helix. So answer should be thymine. Yes, that's okay. So all
So
your
that means even adenine will have 2 bonding sites, right? So
okay, now adenine and guanine both are purines. They will have 3 hydrogen bonding sites. Because if you look at the structure, there'll be one double bond though, there'll be one N, there'll be another C double bond though, right? 3 sites will be there, right? Whereas these are single membered rings. Whenever you have only single membered rings, whereas your purines are double membered rings. 2 rings will be there like this. Okay, so those will definitely have 3 hydrogen bonding sites, whereas your thymine, uracil, and cytosine will have only 2 hydrogen. This will have 3 and this will have 2. Right? Again, uracil we cannot take. That doesn't make sense because it's going to be RNA. So the perfect answer will be thymine is the answer for this question. Okay, right. Next, at which pH of an aqueous solution where lysine will have the amino acid is Vitro-ion formation? That indirectly what they're asking you to find PI. Is it not? Isoelectric point. Is it not? Right? Fine. So in this case, how do you calculate this? Right? Now, if it is going to be a basic amino acid like lysine, right? We need to take remember for basic amino acids. Right? We will take the pKa of the NH4 plus alpha NH3. No, we cannot take the pKa of the R group because the R group will contain this NH2, right? R group will contain this NH2. So that you have to take. This is what is your R plus pKa of the acid part divided by 2 will be the answer, right? So for this, it will be 10.53 plus for the acid, it is going to be 2.18 divided by 2. And that would be how much? 12.53, 12.63, 12.71 by 2. That will be 6 point something. The answer is not matching. 1 second. Then what do I need to do is if I take this and this, what will be the answer? 8.95 plus 10.53. So 8.95, 18.95, 18.95 plus 0.5. 19.45, right? 19.50. Sorry, I'll just do this. 8.95, 10.53, 8, 14, 9, and 1. 19.40 divided by 2 will become 9.7. Yeah, the answer will be 9.7. Right? So remember that we have to take the pKa of the alpha NH3 and the pKa. I'll write everything again for you. 1 second. Just give me 1 second. I'll just add a page and I'll write it here. Okay. So for basic amino acids, that means, okay, PI, the isoelectric point is calculated as pKa of the R group, because the R is going to contain the NH2, plus the pKa of the alpha NH3 divided by 2, right? And if it is going to be for an acidic amino acid, that is, say whenever the R is going to contain COOH here. right? Whenever you have that, you will take the isoelectric point to be pKa of the R, which is nothing but the acid containing group, plus the pKa of your alpha COOH. When I say alpha COOH, the main COOH, right? Divided by 2 is what you will do. Okay, so for basic amino acids, 2 NH3 value you will take. For acidic amino acids, 2 COOH value you will take. That's it. For neutral ones, NH3 and COOH you take. Okay, I hope that makes sense. Yeah.
Sir, for nucleophile, we won't take C group, R group, right?
For what? For
neutral.
For neutral.
Yeah.
For neutral, I'll write. Wait. Yeah, for neutral will not take the R thing. Absolutely, that's true. Okay, so for neutral amino acids, you will take the pi isoelectric point to be pKa of your alpha NH3 plus the pKa of your alpha COOH. That is, R does not include it, divided by 2 is what you will take. Okay. Right. Next question. We'll move on. Right. Write the main structural difference between DNA and RNA of the both bases name. This is so common to both RNA and DNA. You know everything. So many times you have seen this, right? Thymine, uracil is what going to be the difference, right? And obviously, in terms of deoxyribose and ribose, that is also going to be different in between RNA and DNA. Right. Okay. Next, define vitamins and state that classification. List with 2 vitamins of each type. Vitamins, how do you define them? Okay, fine. The classification is very simple. Vitamins can be of 2 types. Either they can be fat soluble vitamins or water soluble vitamins. And water soluble vitamins are A, D, E, K. All the other vitamins are fat soluble. Vitamin B, vitamin C, all those will come here. B, C, all those things will come here. Okay, and how do you define vitamins? Question. Search them in Google, what Google says.
Vital amines.
No, they are not amines. Any group of organic compounds essential for normal growth and nutrition. That's it. This is how you define it. Right. What are vitamins? Essential micronutrients for an organism is in small quantities for the proper functioning of its metabolism. Normal definition you can write. It's not like you have to define them like proteins are polypeptides, polysaccharides are, polyglycosides, right? Not like that. They're going to have different structures. Okay. Fine. Next question. Right. Write the disease caused by the vitamin deficiency of A, B2, B6, B12, C, D, and K. This and all are memory based. Even I don't remember. For A, I think it is going to be night blindness. Okay. For B2, it is going to be beriberi. Right. And vitamin K deficiency, vitamin D deficiency, I think you'll get some skin related issues.
Sir,
The vitamin K, it is blood clotting related issues.
Blood clotting.
No, I think for B1 it is beriberi, sir.
For B1, 2 is beriberi.
Sorry, voice is breaking.
The
Sir.
C is it's scurvy.
Scurvy, okay.
Sir, for B12, it is deficiency of hemoglobin.
Wait 1 second. So A is blood clotting. Okay, and someone said
voice
C
is
is scurvy. Vitamin C is scurvy or vitamin D is scurvy.
C is scurvy, sir.
C is
Okay,
correct.
okay, C is scurvy. Vitamin C is, I think it's C, right? Okay, next. Vitamin B6.
Sir, B12 deficiency of hemoglobin.
B12 is deficiency of hemoglobin. Okay. Right. And B6, I think B6 is very, very important.
So I think B2 is chylosis.
B2 is, what is it?
Chylosis.
Can you spell it?
CHEILOSIS, sir.
L. Okay, G losses. Okay, fine. Yeah. This is not very based. There's no logic in these things. You have to understand it. There's no other way. Okay. Fine. Moving on.
So your voice is breaking.
My voice is breaking. Excuse me, sir. Your voice is breaking. Okay. Now is it fine?
No, sir.
No, sir.
Give me 1 second. Okay, guys, is it fine now?
No, sir.
Yeah, yeah. Okay. Another thing. Now, is it fine, guys? Now?
Sir, could you speak?
Yeah. I'm
No, sir,
speaking.
no, sir, it's not
So it's
fine,
not.
sir.
Okay, I will join again.